Hello, my name is Christiane Schmidt, and I'll be talking about validation of controller workload predictors at conventional and remote towers, which is joint work together with Billy Josefsson, Lothar Meyer, and Maximilian Peukert from LFV, and Tatjana Poliszczuk, who is also from Linköping University. So if we look at navigation service providers, one aim is to have a well-balanced workload level for all air traffic controllers during all operations. So if we want to ensure that, we need to be able to have an objective assessment of the workload to always find the right level. Problem with that is that workload is a subjective concept. So it represents the cost incurred by a human operator to achieve a particular level of performance. And that depends on each single person. So we cannot measure it directly. So what do we need? We need quantitative measures that correlate with the controller workload. And there exist quite a few studies on quantitative workload predictors for en route traffic. However, that's not true for aerodrome control, and it's even less true for remote tower control. So when we talk about remote tower control, what do I think about then? Remote tower services allow air traffic controllers to monitor traffic from airports remotely while they are sitting in a remote tower center. And in particular, it's possible that a single air traffic controller controls several airports simultaneously, which is then called multiple mode. So why are we interested in looking into workload assessment? We have worked on staff planning for remote tower centers. And if we plan for staffing of the remote tower center for the future, we need to make sure that at no point in time we assign airports to an air traffic controller which have a traffic inherent situation that would directly yield to unacceptable workload for the air traffic controller. And in particular, if we have multiple mode, we need to take the traffic scenario and all other influencing factors from those different airports into account. And so what we need to decide is, in which scenario do we need extra staff? In which scenario do we need to assign this airport to just in single mode to a controller instead of having several airports assigned to a controller? What are thresholds here? So we want to figure out, when does the workload associated with traffic of one or several aerodromes exceed moderate workload? So in the previous work that we have done on staff planning, we have taken the number of IFR movements as a first approximation, but of course there are lots of other influencing factors. There's ground traffic, there is weather, there are VFR movements, and all of these somewhat play a role. So we want to find better ways of planning. So what I'll be talking about here today is the relation between subjective workload ratings by controllers and several quantitative measures. And what we'll in particular look at are the number of ATGO tasks, and I'll define exactly what that is, and measures related to the communication lines of the controllers. And so the overall goal is to validate quantitative workload indicators on their power to predict workload in both a conventional and a remote tower. So I'll first introduce you a bit to the setup. What did we measure? How did we measure it? When did we measure it? And what are we looking for? So the first thing, let's look at workload and workload rating. So what do we mean when we talk about workload? So an air traffic controller has several responsibilities. First, of course, to ensure safe separation of aircraft at all times, and to reach the destination in time, so at least close to what is planned in the time schedule. To achieve these things, the air traffic controllers perform various tasks, and those drive a mental workload. And then we can distinguish two concepts. One is task load and one is workload. Task load measures the objective demands that come with the controller's monitoring task, while workload measures the subjective mentally experience stress during tasks. So this differs from person to person. And if we look at all factors that are external to a human operator, then they result in stress. So we have an individual workload, and that depends on different properties of the human operator. So in this case, for example, the length of time that someone has worked as a controller, the length of time that they have worked in a remote tower or at that specific airport, but also performance indicators and what stresses someone and so on. So how do we, now that we know that this is a subjective concept that is individual for each single person, how do you assess it? So there are different scales that have been used to assess workload. One is the adapted Cooper-Harper scale, where we have a rating from 1 to 10, where the question is, do we have full situational awareness, or does it result in a reduced situational awareness? So here 7, 8, and 9 indicate that the situation is solvable for the controller if the ADCO works with some reduced situational awareness. And we have 1 to 3 in a block before, and 4 to 6. There exist other scales, for example, the instantaneous self-assessment scale. Here we have a scale from 1 to 5, and both of these scales are used for self-assessment. So in this case, the air traffic controller is queried, and they answer with a number reflecting the workload that they experience. And so we will use both of these. We had different study setups where different scales were used. So we also provide an approximate way of how to transfer one to the other, but that's just an approximate way, and we're not going to use it in the results, just for you to give you an idea of how they are related. And if we look at our studies, they were not planned as a stress test at the boundaries of the capabilities of the controllers. That means we do not reach those very, very high workload ratings where ADCOs are working with reduced situational awareness, or where they are not able to handle the situation. And in fact, only those ratings that are in red appeared at all. And then I said, well, look at different quantitative measures, and one that I mentioned there are ADCO tasks, or ATs. And so we classified them into different categories, and that's arrival, so everything that's related to arrival, clearance, communication, abnormal situation. But we're actually not going to name abnormal situations as a specific task, because if we have an abnormal situation, that induces several other situations, and we will count these, all those that appear in connection to this abnormal situation. Then we have departure, we have secondary tasks, where so we'll have a simulation study where certain secondary tasks were asked of the controllers, so they should perform something for one of the two airports in the setup. And then we have taxi. So that's one of the quantitative measures, but we also looked at quantitative measures based on communication duration. So why? Well, if you only count ADCO tasks, then you treat all of them equally. So there is no differentiation possible. But some of them might have a higher impact on workload than other ADCO tasks. So we look into communication, which is a very basic task for controllers, and that's using the audio acoustic channel. And if the communication need increases, then the task load increases. So it's so far only the task load, not the workload. But the idea is to integrate the length of the communication related to those different ADCO tasks. So we will weigh the ADCO task with the length of communication that is necessary for those. And we'll use two different types of weight. One is the average communication time for an ADCO task, and the percentage of the total communication time for AT types. So what's the idea? Well, both might indicate an increase in workload. The rationale there is, well, if an individual call related to AT1 takes up more time than an individual call related to AT2, then that might be caused by longer phraseology or an increased need for callbacks for AT1. And so there will be a longer time of attention for these calls, and that might result in an increased workload. And the rationale for the second one is, so for the percentage of the total communication time of AT types, the total time spent for communication related to AT1 is longer than the total time spent for communication related to AT2. So what we'll assume is that the sheer number of these calls leads to a higher attention for these calls. What else do we look at? Well, we also have spam queries. So you can have probe questions during experimental studies to measure the situational awareness. And one of those methods there is a situation present assessment method, SPAM, where the controller reaction times to questions related to the current scenario are measured. And proper situational awareness is indicated by a low latency and by a high accuracy. And so what could a possible question be? What is the actual wind speed for Sundsvall and Örnsköldsvik? Those are the airports that we will look at. And then we measure from the end of this question to the time that the controller answered that question. Finally, I'm going to tell you a bit about how we evaluate our results. So the goal is to have quantitative indicators and figure out how good they can predict controller workload. So what does that mean? What do we want to predict? We want to predict the increases and decreases of controller workload. But we know that workload is an accumulated metric. So there is not just one factor that drives the controller workload. So we need to identify those factors that influence the workload. And a classical way to identify this influence is to look at correlation of one factor or a combination of factors and workload. We will look at a slightly different way here. So we will also look at other criteria that enable us to explain increases and decreases of workload rating. And to do so, we will borrow very classical mathematical notation. So a measure constitutes a necessary condition for workload increase if every workload rating increase is accompanied by an increase in the measure. So you will never be able to observe an increase in workload rating when we do not also observe an increase in the measure. However, there could be increases in the measure that do not lead to an increase in the workload rating. And to also capture that, we have that a measure constitutes a sufficient condition for workload increase if every increase in the measure also yields an increase in the workload rating. So the increase in the measure is sufficient to also say that the workload rating will increase. And simultaneously, or in the same way, we define a necessary and sufficient condition for workload decrease. So what does that mean? So let's assume we have a sufficient measure for workload increase. Then we could only observe the measure because we would know that each increase in the measure would directly yield an increase in workload rating. And so we could predict increases in workload rating by looking at the measure. And if we could find a measure that is a sufficient condition both for workload increases and decreases, then the measure would yield a perfect predictor for workload changes. So what did we actually do? So what's the study that we had? We had two studies at two different locations and two different locations. One was a field study at a conventional tower at Bromma Airport and a simulation study in a simulated remote tower, both in singular and multiple mode for two different airports, Örnsköldsvik and Sundsvall, and the simulation was located in Sundsvall. So for the field study that was performed on March 4, 2019, during actual operation at Bromma Airport, We had 5 video cameras. 2 were directed toward the controllers, for example, toward the flight support, and 2 were directed toward opposite ends of the runway to record the traffic. And then we used those videos to reconstruct the ATCO tasks. We had 2 ATCOs and 1 assistant, altogether 3 ATCOs observed for 4 hours, of which 1 was female, 2 male. The mean age was 43, and they had worked as an ATCO for a mean time of 19.6 years. And we used the Cooper-Harper scale, the adapted Cooper-Harper scale, to assess the workload. So we queried them every 5 minutes to give us a verbal workload rating. And in the beginning, we did that every 15 minutes. And so that yielded a sample size of 45. And we also measured the length and the purpose of communication. So for the simulation study that was performed during May 6 to May 17, 2019, here we only had the 3 video cameras toward the controllers because we know the traffic in the simulation. We again had 3 controllers, 2 female, 1 male. The mean age was 52. They had worked for a mean of 23.3 years as controllers and for 5.6 years in a remote tower center. In singular mode, we always had 5 movements per simulation run, in multiple mode 6, and each simulation run lasted for 75 minutes. Here we use the ISO scale, so rating 1 to 5, and we queried the workload from the ATCOs every 3 minutes, which yielded a sample size of 25 per controller. And we also measured the length and purpose of communication, as we did in the field study, but this time also the reaction time to SWAM queries, because that's possible in the simulation. And what I can add is what we observed in the field study. So we had snow sweeping with a convoy of 10 to 14 vehicles repetitively during those 4 hours of observation. And the movements per hours varied from 4 in the first hour to 27 in the last hour. So what are the results of our field study? Here you can see, so let's only focus on ochre and pink for now. Ochre is the workload ATCO, the self-assessment rating, and pink is the number of ATCO tasks. And our conjecture was that an increase in workload rating is always accompanied by an increase in the number of ATs in the current or previous time period. So what does that mean? If we look at an increase, for example, here, well, then we say that either now or in the time period before, the pink thing has to increase. Well, it didn't in the current time period, but it did in the period before. So why do we look at 2 consecutive time points and not just in this one interval where we observe the increase in workload rating? Well, the idea is that ATCO tasks accumulate, and then they can result in increased workload rating at the following query. And so our conjecture holds. So if you check all workload rating increases, then that's true. So we have a necessary condition, but the converse is not true. What does that mean? Not every increase in number of ATCO tasks also leads to an increase in the workload rating. So for example, here, in this period, the number of ATCO tasks increases. In the period before, it was constant. So that would fulfill this number of ATCO tasks in current or previous time period increased, but the workload in that stays constant. So we have a necessary, it could be a necessary condition, but it's not a sufficient indicator for an increased workload. So that was just looking at the number of ATCO tasks. As I said, we're going to weigh them because we don't think that all ATCO tasks have equal impact on the workload rating. So we looked at the different ATs and we looked at the communication split. So in orange, you see the average call duration for each ATCO task type. So the average call duration related to taxi lasted 10.7 seconds. And then in green, we have the sum of all the radio call durations for each AT type. So all the radio calls related to taxi lasted 321 seconds, and in total, all of them lasted for 2,531 seconds. And then in turquoise, we have that expressed in percentages. So those 321 seconds for taxi are 12.68% of all of the communication. And those are the numbers that you can also see in this pie diagram at the bottom. So what can we observe? Well, the clearances have the highest average duration of each call. And that could be because for clearances, they are initiated by one party, then the other party replies, and then we wait for repetition to confirm proper reception. And that's in contrast to all the other tasks. So we have more or repeated interaction here. But if we look at the percentage of the total that is actually spent on clearances, then that's 18.49%. So that's not extremely much. But what we can see there is that ground has a very high value. And what you can see here is that the snow cleaning is clearly represented. So for the snow cleaning, you need to repetitively communicate with the ground traffic. And so that yields a very high value here. Okay, so we're going to use them now for weights for our ATCO tasks. And first we use a percentage of the total communication time. So now we look at still the ochre for the ATCO workload, but now at the violet line for the ATs weighted with the percentage of communication duration. And so our conjecture is, again, an increase in workload rating is always accompanied by an increase in the ATs weighted with the percentage of the total communication time in the current or previous period. And so here, for example, we look at that increase, we have an increase in the current, but a decrease in the previous period. And again, if you check all workload rating increases, you can see, yes, this conjecture holds. So we have found another necessary condition for increasing workload ratings. So those ATs weighted with a percentage of the total communication time in the current or previous time period. And now we'll look at the other type of weight, which is the average communication duration. So we have, again, the ATCO workload in ochre. We have the sum of, we have the ATs weighted with the average communication duration in green. And now we'll also look at the sum. So because we always looked at both the current and the previous time period, we now with the sum of these two. So this gray data point is the sum of this green and this green. So there's just to have an idea what that means. So what do we say now? Well, any increase in workload rating is always accompanied by an increase in at least one of, so it's an or statement. So either at least one of these has to increase then. The average communication duration weighted ATs in the current or previous time period, or the sum of average communication duration weighted ATs at the current and previous time period. So how does it look like? For example, here we have an increase in workload rating. So do we actually have a necessary condition here? Well, the previous one, the average communication weighted ATs decrease, but in the current one, they increase. And if you look at the gray one, that's also. So we have a necessary condition again, if you check all of them, but it's not a sufficient condition. So why? Well, if you look at this point in time, the gray, so the sum increases. If you look at green, it increases in the current, decrease in the previous. So that's still, yeah, those are both are present. That would say if it's a sufficient condition, the workload rating now also must increase, but it decreases. So we have a necessary condition, but not a sufficient condition here again. And actually this on itself is a necessary condition. So we don't have to say an increase in at least one of, but just looking at the sum of these, so the gray graph that will represent a necessary condition. So just a brief note on this field study. The average workload rating was higher in the first 3 hours, during which snow sweeping occurred, than in the final hour with peak traffic. So in the final hour, we had 27 movements, but no snow cleaning. In the 3 hours before, we had 4, 5, and 9 movements, but snowfall and snow sweeping, and the workload in those first 3 hours increased significantly in comparison to this last part. So we need more data to really study this influence of weather in detail, but it's a first hint that weather really plays a major role in the impact of workload. Okay, so let's look at the simulation study. The communication split are the weights for our ATs. So now we looked at different ATs and at how much time did the ATCO1 spend in single on average on that and in multiple. And then we build the average over all ATCOs in single and overall in multiple. And if we compare single and multiple, then the only thing where we can observe a significant higher communication duration in multiple than in single mode is communication. However, the other increases are not significant, so 2 of them are nearly significant. So for average communication times related to arrivals, we have a nearly significant increase, and the same for clearances. And the last one is probably due to risk compensation behavior by the operator. So you want to avoid a risk, so you pay for that in time. And what we did is we normalized the weights, so scaled down to 1 and then the other in relation, and we used the average overall single for our single mode consideration and the average overall multiple for our multiple mode analysis. So first, let's look at single mode. We have ATCO1, ATCO2, ATCO3, and workload is again occur. All ATCOs had endorsements for Sundsvall. The ATCO3 definitely has the largest workload variations. So that could be explained by less experience as an ATCO, so 9 years in comparison to 30 and 31 years. So let's look again at our conditions. The number of ATCO tasks is not a necessary condition here. So we can forget about that. That's not working, even if it worked in the field study. So let's look if we get valid ones out. If we look at the communication time related measures that we had before, then they are not valid for all ATCOs. But what we'll do is we'll also look at the following period. What's the rationale behind that? Well, an ATCO anticipates already later tasks and prepares for them, so that can also increase the workload rating. So that will yield us a necessary condition. An increase in workload rating is always accompanied by an increase in, for ATCO1, all measures related to communication, so that's very nice. For the second ATCO, the sum of the average communication duration weighted ATs for 2 consecutive time periods, so that's a gray thing again. As an example, we look at an increase here of workload rating, and that's accompanied by an increase in this gray measure. And for ATCO3, in the average communication duration weighted ATs in the previous, current, or following time period. So in the green thing here, workload rating is increased, and it's going down in the previous, down in the current, but up in the following time period. So let's look at multiple mode. Just a note, ATCO3 was stressed because of problems with simulation equipment, so we started at 909 instead of 900 for that ATCO. ATCO1 had the longest RTC experience, but an endorsement only for Sundsvall. So that controller was working in a new working environment, which wasn't true for ATCO2 and 3, which can explain a general lower level of workload rating for ATCO2 and 3 in comparison to ATCO1. Okay, can we get a necessary condition again? Yes, we can. Every increase in workload rating is always accompanied by an increase in at least one of the duration of communication during that time interval in blue. Again, this grazing sum of average communication duration weight, ATs. So let's look at this. We have an increase, and it's accompanied actually by an increase in both measures. But we actually need increase in one of, so here, increase in workload rating, gray goes up, blue goes down. Well, we have increased at least one of, that's true. And let's look at here. Yellow goes up, workload rating goes up, gray goes down, but blue goes up. So we have a necessary condition with at least one of those. And if we look at the field study, then it's actually comparable to the necessary condition there. It's all related to communication time and ATCO tasks. Again, what we can say here, the number of ATCO tasks is not a necessary condition for increase in workload. So this we can exclude. So now we have all these conditions, including communication lengths, but the question is how exactly. I mean, currently we would say in at least one of, but of course it would be nice in the future to have a combined measure of these. And then last, we looked at reaction times for multiple versus single. So here you see for the different spam queries, the reaction times always first ATCO1 in single, then in multiple, and so on. And mostly, the reaction times increased in multiple mode versus single mode. And that might be because the controller is confronted with more tasks. So you might be less responsive and exhibit risk compensation behavior. And there could also be some insecurity included. So the ATCO double checks to avoid mistakes. That results in a slowdown, and that can be an indicator for uncertainty. And this uncertainty is one of the main stressors, so that could be an indicator also for workload. But the trend is not true for all queries in ATCO. So for example, reaction time from ATCO 2 for spam, track, and clearance multiplier is lower than single. So you can see that here for track and here for clearance, even if only a little decrease, and the same is for ATCO 3 for 3 of the cases. And again, ATCO 1 had RTC experience, but no endorsement for Sundsvall. So there was a new working environment, and that might explain the increases from single to multiple mode, while the others had endorsements for both and RTC experience. So that it can explain smaller increases or decreases. And altogether, that underlines the importance of training to reduce stress. Okay, let's look at conclusion and outlook. So we studied the relation between subjective workload ratings and quantitative measures. And we identified a necessary condition for increase in workload rating over all ATCO ratings in both the field and the simulation study. Each increase in ATCO workload rating is accompanied by an increase in at least one of those. The ATs weighted with a percentage of the total communication time, the average communication duration weighted ATs in the previous, current, or following period, the sum of those for the previous and current time period, or the duration of communication during that time interval. So we validated these indicators on their predictability of workload increases. And all these criteria are related to communication time. Simply counting the controller tasks is not a good workload indicator. It's not a necessary condition. And having this necessary condition can give us insights into workload development. And a sufficient criterion would be even more beneficial, of course, because then we really could predict workload increases. So that's part of future work. But our result also indicates that other factors, so for example, the mental workload for decision-making without measurable indicator, this one, might even out variations in those communication time-related measures. So there's variation, it doesn't impact the workload rating. That might be due to other factors that we cannot measure. Or it might be that our workload scales are not fine-grained enough. So it's 1 to 10, 1 to 5. We only have those lower parts of the scale. You might have a change in the workload, but it is not represented in the rating. So it might be that they still actually yield a change in workload. So what would be the overall goal for the future here? To also have a sufficient criterion for workload rating decreases. And then a combined quantitative workload predictor from those two. So what else could we think about? We used communication data for the full study period as weights. They can be derived from large data sets, that's nice. And they could then lead to predictions of workload. What we also could look at is how does the communication length for each ATCO type develop over time, and then study the correlation between this progression of communication lengths and the workload. But we could not use them for predictions. What else? Well, we used isoscale and Cooper-Harper scale for workload rating, but we only had really small variations in workload. So the scales are really good in determining whether we have an unacceptable level of workload or no reduced situational awareness. But having those small variations, they are not reflected equally well. And then the ATCOs were not familiar with the scale, but they are just numerical, so they might just guess a reasonable number. And then there's this factor of social desirability. When you query them, they don't want to say that they're overloaded. So all that together means we need an instrument that is able to register even small variations on lower workload levels. So that would be another director of future studies, and moreover rely to integrate measurements of other factors. For example, runway friction as a predictor for increased workload due to snow and so on. And possibly we could also just look at a physical measurement like pupil diameter that has a high correlation to workload. And then as a goal, just measure this empirical measure instead of actually needing to access the workload. So that was it. Thank you for your attention. If you have questions, slightly different format, so please feel free to send me an email. If you would like to have the slides, please go to my website and you can find them there. And with that, thank you for your attention.